Okay, I'm going to encourage you guys, find a space on your sheet to write that down, okay? Find a space on your sheet to write that down, probably up above, right under the heading. Again, this is the mean value theorem. And again, the mean value theorem says that if you take the average rate of change of the function over a given interval, there is a point, C, that exists within AB such that the derivative at C is equal to the average rate of change. Now, again, you're now used to the fact that you're not going to necessarily understand it all the first time through. But as you look at this over the course of a couple days, it should start to sink in, but you should know what this means. You should be able to interpret this. So someday if you see this, you should be like, oh yeah, that is average rate of change or slope, right? That is the derivative at a specific point. That's saying that the point lies within the interval. That's what we want to be able to do. Everybody got it? Okay. We move to the first page. Mr. Gins, here we go. The directions are as follows. It says, use the mean value theorem to find equations for lines tangent to the curve that have slopes equal to the average rate of change of the function over the given interval. Basically, what this means is use the mean value theorem. That's the whole point of this. We want to confirm our answer by graphing the function and the tangent lines and provide a sketch here. Okay? So, we'll do the first one together, and then we'll do a trig one, we'll do a rational expression one, and we see where we get. Okay? The first step is that I must use my mean value theorem, which again says f prime of c is equal to f of b minus f of a all over b minus a. So, what should you do first in this scenario? Before I even find the derivative, let's find the average rate of change. Okay? How do I find the average rate of change of this function over this interval? Yeah, let's make a list here. I got A, I got B, I got f of A, I've got f of B. Okay? I'm sorry, I have a mistake. Won't be the last. Different bracket there. So, what is my A value? -4. What is B? 1. What is f of A? If we plug in -4, what do we get? Very good, you get 0. What if you plug in f of b? 5. So what we want to do now at this point is we want to come up with, these are my leftovers, right, Andy? We want to be able to come up with the average rate of change. The average rate of change will be f of b, which is 5, minus f of a, which is 0, divided by b, which is 1, minus a, which is -4. What does that give me? 1. Yeah, that is the average rate of change of the function over that given interval. Yes, the slope from -4 over to 1. Yes. We are going to take the derivative right now. So what I've done is I have worked with this side of the mean value theorem. I've figured out the average rate of change of the function over that given interval. What we want to find now is where the function has that instantaneous rate of change. Once again, if it takes me an hour to get to Mankato, and I drove 70 miles, true or false, at some point I had to be driving 70 miles an hour. True. You can't always drive less than 70, otherwise it would take you longer. You can't always drive greater than 70 miles an hour, otherwise it would take you shorter. So we know that that's the case, all right? Same idea with the mean value theorem. So we have our average rate of change. It is 1. Now, let's do what Marlene said, which is take the derivative. What is the derivative of x squared plus 4x? Good. So, when I'm solving for x, I'm finding a value for x that is going to be c. X must be between what? -4, 1. It falls within that interval. Excellent. Okay. So, what do I do? I'm I'm going to write things in terms of decimals because we're going to come up with a lot of decimals in this worksheet. The goal of this is to write an equation for a line tangent. What two things do you have to write an equation for a tangent line? Slope and point on line. What is the slope? Slope is 1. What is the x value of the point on the line? Negative 1.5. That's what we just found. What do I plug it into? Do I plug it in the derivative or do I plug in the original? Original. If I plugged it into the derivative, what would I get? Oh. You guys were listening. Was this your New Year's resolution? Did you say? You guys were sitting up. It was 2 o'clock in the morning, New Year's Day, and you're like, I'm going to make a New Year's resolution. I'm going to listen to everything that comes out of the mouth of Mr. Gentz. Okay, so somebody plug in negative 1.5. What do I get? So now I'm going to write my equation for my line. Here's my equation for my line. I have y, which is negative 3.75, equals m, which is 1, times x, which is negative 1.5, plus b. Add my 1.5 to both sides. I will get negative 2.25 is equal to b. So the equation for the line is what? Excellent. You guys, if you can understand, now again, we just did a basic polynomial. Again, we have some trig, we have some rational expressions, we got all sorts of things we're going to deal with. But that's the essence of the mean value theorem. Like I said, I probably just didn't do a good enough job explaining it last year. It's my first year doing it here. We want to understand this very well. This is very useful, especially later on when we get to integral calculus. Now, what I want you to do is I want you to confirm this graphically on your calculator and sketch a graph. So I turn on my calculator, I plug in my original function, which is, I get rid of this, x squared plus 4x. And then I'm going to put in my equation for my line, which is x minus 2.25. And when I do that, what should I see? I should see that the line is, it would be parallel. Well, we don't have that imaginary line drawn, do we? Well, we'll see a line tangent, but as you can see here, it's from, we said, negative 4 to positive 1. So if you go from negative 4 right here to positive 1, which is right here, if you were to draw that imaginary segment that we talked about yesterday, you're right, they would be parallel. So what I want you to do, though, is I want you to be able to confirm that by drawing it graphically right here. And just a quick sketch, you guys, just to show that you've done it, okay? So we'll make a quick sketch. And when I mean a quick sketch, I just mean to draw, that type of shape. Because, again, I know, this is a parabola, and you guys know exactly what that looks like. But what happens when we get something that you're not so sure what it looks like? That's going to be entirely different. Okay? Again, can we pause and reflect and say that had you been asked to do that at the beginning of the year, you would have been like, no way, that's impossible. It's magic. Thank you. Mark. Isabel. Benjamin. Okay. Let's try a different example. Flip over to the next side. Yes, 6. Thank you. Excellent, Taylor. Good insight. Why did you say 6? What looks difficult about it? And the x over 2. Okay, excellent. This is what we want to do. Okay, we're going to deal with this cosine of x over 2. Now, just some foresight, you guys. How often does the graph of cosine repeat itself? Every 2 pi. If you divide by 2, then how often is it going to repeat itself? every 4 pi. It's going to be half as often, okay? Half as often, twice the interval. We start out the same way. Am I working in degrees or radians? Radians. Again, for those of you who wonder, when do we work in degrees? Yeah, unless there's a degree, you're not using it. So we check our calculator's mode to make sure that we're working in radians. We are. Y equals, we type in cosine of, remember your parentheses, x divided by 2. And I'm going to go to my table to quick generate my values for 0 and 10. 0 is 1. We're going to get some decimals here. 0.284. So my A value is 0. My B value is 10. So I've got all the pieces I need to find the average rate of change of that function over the given interval. What now? .284 minus 1 over 10 minus 0, or 10. 0.284 minus 1. Negative 0.716 over 10, which is, say, negative 0.072. What does negative 0.7072 represent? Over that interval, the average slope, the average rate of change over that given interval. And the mean value theorem says there must be a point on the graph where you have an instantaneous rate of change equal to that average rate of change. So I have to take the derivative of that. Yes, no? Okay. If you need more space, attach a separate sheet of paper. I'm going to work in a little bit bigger space here. Okay. That's my function. That's my slope. I need to take the derivative of this. What do I have to use? Chain rule. Chain rule. I know that you thought about maybe using the quotient rule, but again, the quotient rule, if we had, say, x squared minus 1 over x, then that might be a quotient rule situation. This is just a 1/2 x on the inside. The deal is that you have a rate of change happening here, and then cosine of that is another rate of change. Thus, the chain rule, you have two moving parts here in this case. So, okay, we'll make our boxes. What's f of u? Cosine of u. What is u of x? X over 2. What's f prime of u? Negative sine of u. What is u prime of x? 1/2. Multiply them and substitute back in. We have 1/2, negative 1/2 sine of x over 2. Very good. So our derivative is set equal to that. Negative 1 over 2 sine of x over 2. What to do, what to do, what to do? Hold on, before question here first. Negative 1 over 2 times sine. Okay, so I've set them equal to each other. Now what do I do to both sides? Divide by negative 1/2 or multiply by negative 2. So we have sine of x over 2 is equal to, what is negative 0.072 times negative 2? I got negative 0.144. Oh. So 0.144. Okay. I have to solve for x. How do I get rid of the sign? Good. Sine inverse of both sides. So we got x over 2 is equal to, we need to do sine inverse of, oh, you guys are going to love this, sine inverse of 0.144, and I get, oh, 0.1. What are the odds? Okay. That's kind of cool. All right. No, it won't. Definitely will not always happen. What's that? Oh, how is the derivative of this 1/2? Because you have 1/2 x. That's x over 2. Okay. All right. No. No, hold on, you guys. Hold on. Now, everybody pause, okay? You guys, you're understanding a lot of things about mean value theorem, but now we're trying to apply them to all sorts of different functions, not just polynomials. So just pause here and watch this so you can appreciate and understand, okay? Yesterday, remember when we started out, I had you draw all sorts of shapes like this? And you connected the dots, and you know, then we tried to estimate, right? Well, how many lines do you have for this problem? Good, you have 2. You have, one like right there. You have another one like right there. Well, we very well might have more than one for this function. Don't make fun of my drawing. So, what you're going to have here is we have to ask ourselves, where is sine positive? All seniors do calc. All seniors take calc, not do calc. First and second, very good. So we got a reference angle of 0.1445. No. No. This is trig. We have to find out where sine is equal to 0.144. And it's equal to 0.144 at 2 spots, wherever the reference angle is equal to 0.144. Okay? And so if you remember, this is 0 or 6.28. What is this over here? 3.14. So I know one angle, so I know x over 2 is equal to 0.1445. And then I also know that x over 2 is equal to, how do I figure that out? Hey. All right. We are going to multiply by 2 right now. Okay? Yes. Yes. Yeah. 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 Ina is the voice of us all. Okay, very good. Okay. People, let's finish it off, okay? Let's finish it off. We got x over 2 equals 0.1445 and x over 2 equals 2.995. What do I do to solve for both of them? Multiply them by 2. So you have x is equal to, what is 0.1445 times 2? 0.289. What is 2.995 times 2? 5.99. Now, are those values are they within our interval? Yeah, so that's very important, yes. Okay, you guys, Chrissy asks a really good question, and she asks a question that not many people have thought about. if our interval didn't go from just 0 to 10, let's say it went from 0 to 100, we would have, probably about, 20 different points. The only way you're going to really know for sure is by looking at your interval and looking at your graph. Now, I've tried to limit it, and I made up these problems last night, but I've tried to limit the answers to just being, for the trig ones, to 2, okay? So, but just check to see if it falls within the interval, and you'll look at the graph, and that's what we want to do, okay? And you guys, this is a long problem. This is involved, but you understood what we were doing right away, so we want to give this a shot. Yes. Right. But if let's say one answer came out negative, for example, then that doesn't fall within your interval, so you wouldn't use it. If within the interval, if sign repeats itself more than once, then you're going to have a repetition. You're going to have, say, 4 lines then. Okay, look. Yeah, look, I've got, tangents of 0 there, and they'll continue on forever. I mean, you could have a lot of situations, you know what I mean? So you got to look at your length of your interval. Okay, let's finish this problem off, okay? And then you guys can start to work. Okay, what is my objective here, you guys? What am I trying to do? 2 tangent lines. So again, if you have to attach a separate sheet of paper, then so do it, okay? So we'll do line 1. We'll do line 2. Okay? What do I need in order to find the equation for those lines? I need slope, and I need a point on the line. What is the slope of these problems? Good. What is the x value for the first line? 0.289. What's the x value of the second line? How do I generate the y values? Plug it into which? The derivative or the original? Good. Plug it in the original. Go to our table. I punch in 0.289, and I get 0.989. I plug in 5.99, and I get negative 0.989. Split you guys right here. Okay, this side, come up with the equation for the first line. This side, come up with the equation for the second line. Okay, we'll confirm it as we will hopefully all have the same one, and then we'll graph them. I won't ask you to do all 16 problems on the worksheet, but you will have to make some choices, and I do want you to do some trig as well as the polynomial ones. So, quick find the equation for the line. What do you got? 1. Does that look right? Group 1? Okay. Somebody got line 2? Minus 0.556. Okay. All right, we'll leave it like that. Okay, those are our 2 lines. Okay. Now what we're going to do is we are going to graph these lines as well as the original function. Take out our calculator. A lot of times you're going to come up with two answers. Yeah, you could. Let's say that you were trying to come up with, let's say, yes. I'll come and show you an example. Okay, I'll come and show you an example. All right. You graph this in your head. Katie Williamson. Okay, here we go. Now, hopefully, I haven't worked this problem out yet. Hopefully it comes out correct. Now, let's think about our window. Our x values need to go from what? What's our interval? 0 to 10. So as long as we're within 0 to 10, we're fine. I'm just going to go from -1 to 11 to make sure I see all of that. And I'll put a scale every one. Our y minimum, what's going to be the smallest value that cosine can have? -1, largest, +1 in this situation. So I'm going to go from -2 to +2. Hopefully I'll see then the y-intercepts if they pop up there. And if we hit graph, hopefully we'll see a graph of that cosine of x over 2. And hopefully we'll see two tangent lines, please. Oh, look at that one. Look at that. Yes. Now, again, our interval was from 0 up here to 10. You can see that average rate of change right there. That's what we're looking at. Okay, here's your assignment, okay? Let us deal with the exponential functions on Monday. What I want you to do right now is I want you to focus on just the first, we did 2 problems together. Focus on the first 8, so work on the other 6, okay? Please give that some time this weekend, okay? So do the easy ones first, okay?